Hey everybody, it's a beautiful day to write some code. Let's get right into it with Leet code number 700. Search in a binary search tree. If you don't know what a binary search tree is, we have a tree of nodes. Each node has a left and a right node. And the cool part about a binary search tree is that we know that our left node's value is going to be less than our current node's value. And we know that our right node's value is going to be more than our current node's value. It's going to come in helpful in this problem. So let's take a look. You are given the root of a binary search tree and a value val. Find the node in the binary search tree such that that node's value equals val, and return the subtree rooted at that node. If such node does not exist, return null. So basically we have this value 2 that we're looking for. We're going to take a look at our root node and we're going to say, okay, is this root node our target value? If it is, we want to return this entire tree that corresponds to that node. If it's not our target value, we have to decide, do we want to go left or do we want to go right? If our target value is less than our current node value, we're going to go left. And then we're going to do the same thing on this node as our root. This is called recursion. So we're going to say, is this target value equal to our value? It is, so we are going to return this entire tree rooted at that node value. If we don't find this node, so say we're looking down this tree and our answer was -1. We're going to start at 4. We're going to say, okay, is this node our value? It's not, so we're going to go left. Is 2 our value? It's not, so we're going to go left again, because it's our value that we're looking for now is -1. Is 1 our value? It's not, so we're going to go left again, since -1 is less than 1. And then we're going to pass in an empty node. In this case, it's going to be a null node. So this is going to be our base case as we're recursing. So we got to find two cases. Our base case, our visiting our current node case, and then our recursion case. So our base case here is going to be if a null node, an empty node, was passed into our function. If an empty node is passed into our function, we could just return none. Our visiting our current node case is going to be, okay, we're taking a look at our current node. Is this the value? If it is the value, return the entire tree. And then our recursion case is going to depend on our value and our current node value. If our target value is less than our current node value, we're going to go left, and we're going to recurse on the left node. If our target value is greater than our current node value, we're going to go right and recurse on the right node. So that takes care of our base case, our visiting our current node case, and our recursion case. Let's jump into the code. So taking a look at the code, as you can see here, we got a little comment section that kind of explains what this node looks like. We have a .value, .left, and .right. So we're going to outline our pseudocode right now. We're going to say our base case is the first thing we want to take a look at, and then we're going to visit our current node. And then we're going to recurse. This is kind of the outline to any recursion problem. So as we discussed, our base case is if the root node that's passed into this function is none. If that is the case, then we know that we have either searched for this node and ended up at none, or none was passed in which case we have not found the node value. So we're just going to return. If root is none, we're going to return none. Now we're going to visit our current node. So we're going to say if root.value, and this is important, this is past the base case since we know this root is not going to be none here. If this is equal to our current value, then we're going to return root. This is the entire tree here instead of just the value. And for our recursive call, this depends on our value and our current root value. So if we haven't found this value at this root node, then we're going to say, okay, is our value, if value is less than root.val, then we're going to recurse to the left. So we're going to say return self.search bst, and we're going to pass in our root.left and our current value. Otherwise, we're going to recurse to the right if our value is greater than our current node's value. So then we're going to return self.search bst with our root.right and our value. All right, let's go ahead and run this and see what we get. Submitting our solution here, fingers crossed. And we passed 0 milliseconds. That's pretty quick. Thank you for watching. If you found this video helpful, feel free to check out the channel for more. Have a good day.